Large herbivores over 100 kilograms, also known as megafauna, are one of the groups most affected by humans. The majority of megafauna went extinct across the continents at the end of the Pleistocene, starting 50,000 years ago, most likely from overhunting by human beings. Unfortunately, these declines continue to this day. 60% of extant megafauna are threatened with extinction. These prehistoric and current declines in megafauna have and are having massive effects on Earth's biota and ecosystem processes, and have led to urgent calls to conserve the remaining species of this important group of life. However, assessments of modern megafauna decline miss something critical. They ignore introduced megafauna species. I collaborated with William Ripple of Oregon State University and Arjen Wallach and Daniel Ramp of the University of Technology, Sydney, to evaluate the extent to which these nominally invisible megafauna contribute to the conservation of this important functional group. We found that worldwide, humans have introduced 22 species of megafauna, which incredibly is 29% of the remaining megafauna species on the planet. Of these, 64% are threatened, extinct, or decreasing in their native ranges. These results suggest that introductions may actually be, in some ways, a countercurrent to extinctions. For example, according to the IUCN, the continent of Australia has 0 megafauna. But in fact, Australia has 8 species thanks to introductions. These include extinct species that have been rewilded from domestic ancestors, such as the wild dromedary camel, whose only wild populations today are in the outback deserts of Australia, as well as non-domesticated species, such as the vulnerable sambar deer. These introductions have restored megafauna species richness on all continents to levels approaching the Pleistocene. For example, 15% of Asia's lost Pleistocene species richness, and 67% of Australia's has been restored by introductions. This suggests that these species may in fact restore lost ecological functions in their new homes. And indeed, some research suggests that they do. Some studies have found that introduced megafauna can suppress fire, promote tree establishment by grazing competitive grasses, and maintain desert wetlands for fish and amphibians. Furthermore, our own research on wild burros, or donkeys, in the Sonoran Desert of Arizona has found that they dig wells to groundwater. These water features are used by more than 40 vertebrate species and become germination nurseries for important riparian plants. However, most introduced species are studied under the premise that their ecological effects are by definition harmful. And indeed, introduced, as well as native megafauna, can suppress native species through herbivory and trampling, but these effects are often modulated by the presence of apex predators, most of whom are persecuted globally. Unfortunately, this mechanistic ecological context is generally ignored in research on introduced megafauna. Because of these prevailing attitudes, introduced megafauna populations are frequently targeted for eradication or lethal control, which raises a conservation paradox for the Anthropocene. How do we reconcile local conservation goals to maintain historic species compositions with global goals to prevent extinctions? By eradicating the world's last dromedary camels, are we doing conservation a service or a disservice? Finally, how do we understand and study the redistribution of life in an age of radical change and extinction?